we get through the notice and wonders, they turn and talk, do all that kind of stuff. And then we get to the point where they do estimations, and we're still good with the estimations because they really don't have enough information to really launch into anything. But then as soon as I do the reveal of, we talk about, okay, well, today we're looking for whatever it is, and I reveal the information that they can use to start solving it, they go straight for the calculation without a thoughtful processing of why are they doing that calculation.
You are listening to Karen Huber, a third grade math teacher from San Antonio, Texas. Karen has taken a deep dive with us in our full online workshop. She's a member of the Make Math Moments Academy, and today in this Math Mentoring Moment episode, we talk about how to promote reasoning and proving with our students instead of focusing on just answer getting.
Stick around and you'll learn how to get students to value math strategies over right and wrong answers. What is the 10-10-10 rule, and how you can help think about student learning progressions so that you can give appropriate feedback. All right, let's not waste any time. Let's dive in. Welcome to the Making Math Moments That Matter podcast. I'm Kyle Pierce from tapintoteenminds.com.
And I'm John Orr from mrorr-isageek.com. We are two math teachers who, together,
with you, the community of math moment makers worldwide who want to build and deliver math lessons that spark engagement,
fuel learning,
and ignite teacher action. Welcome, Math Moment Makers, to episode number 67, How to Promote Reasoning and Proving over Answer Getting, a math mentoring moment.
Let's get ready for another jam-packed episode. But first, we'd like to say thank you to all of you math moment makers from around the globe who have taken the time to share feedback by leaving us reviews on Apple Podcasts.
This week, we want to highlight a review from JJBMAW, who gave us a 5-star rating and review that said, "This is a must-listen-to podcast for math educators. Each episode is a booster shot to keep my teaching spirits up and keep me going. I especially enjoy the math mentoring moment episodes." Oh, he's going to love this one then. Really love hearing about other teachers who might have the same struggles as I do and listening to your analysis and advice on what we could do. Each episode gives me a chance to think about my role and how I can do better. Thank you for producing this great podcast. I've been telling my coworkers about your show.
We can't thank JJBMAW enough for taking the time out of their day to not only listen, but help us reach our current goal of over 500 ratings and reviews in the near future. We are well on our way with over 200 ratings and 100 written reviews on Apple Podcasts.
If you haven't taken a moment to go and give us an honest rating and review on Apple Podcasts, we would certainly appreciate it, especially if you're listening from somewhere outside of North America, just to let us know that you're out there and listening.
All right, now, before we get to our math mentoring moment with Karen, we also want to take this moment to give you a quick heads up that our online workshop, Making Math Moments That Matter, will open for registration next month in late April.
We run the online workshop twice a year, and we're running our second cohort for 2020 this summer instead of the fall, based on the feedback we've received from so many of you math moment makers. If you're thinking about taking our online workshop during 2020, then you won't want to miss registration this April 2020.
You can learn more about the workshop at makemathmoments.com/online workshop.
That's makemathmoments.com/online workshop. All right, my friends, let's jump right into the conversation with Karen.
Hey there, Karen. Thanks for joining us here on the Making Math Moments That Matter podcast. How are you doing today?
I am doing fantastic. It's a nice sunny day today.
Ooh, nice. Excellent. That's awesome to hear. And if it's sunny there, that must mean that you do not live around John and I. Where are you coming from? Tell us a little bit about yourself. How long have you been teaching? And maybe take us down a little bit of, I guess it's memory lane with your teaching journey.
Sure. Well, I am in San Antonio, Texas, so we are definitely not anywhere near Canada.
No.
This is probably my third career, if you will. I came to teaching kind of sideways. I got a master's degree in education, and then I went back and got my teaching certification. After I had both of my children, I actually ran their daycare, and through that kind of got into the teaching side of education. And just the early childhood part of my experience has really informed how I go about learning about teaching, because the early childhood is so foundational and it's all about how to get kids to learn through play. And so that's a big part of where my foundation came from. And then I just went back to get through getting my certification and taught in various places. I've taught in Spokane, Washington before we moved here to Texas. And so I've taught 4th, 5th, and 6th gifted and talented students. I've taught 2nd grade, I've taught 4th grade, and I now teach 3rd grade math and science. I am fortunate enough to departmentalize, so I get to focus.
Awesome stuff. I'm always very curious and in awe of teachers of early childhood education. And I also have had significant impact on my career and the way I've been teaching almost since the beginning. The way I think about learning, like you said, I have to relate to that because my wife was a Montessori trained teacher for 10 years, where I guess is a Montessori trained teacher, but taught in a Montessori school for 10 years, has since moved to kindergarten in our local public school. And when I met her, we were both teaching in the Caribbean, and what she taught me about early childhood education is what started immediately having me change the way I've been teaching. And I had only been teaching for a couple of years then, but it just made me think about how learning occurs in students. And I've shared here that many times is that, I never took a lot of thinking into account about who kids were and what they were learning and how they learned. I just kind of taught the way I was taught. But even early in my career, I had those thoughts too about different ways kids learn. And some of that influence, that early childhood learning has influenced my high school teaching career. Like I'm a high school teacher. So I'm glad you said that because I think we should all have that early childhood experience, not necessarily teaching, because I don't know if I could handle teaching little kids, but I think just understanding how little kids learn, like you said, through play, so important. You've kind of given us a little snapshot of your career, but I wonder if you could stretch back in time too. Like, what's a memorable math moment for you if you think about your schooling and the way you learn math? Could you share a math moment for us?
Sure. When I'm thinking about this, it's hard for me to pinpoint one exact moment, but I think throughout my entire schooling, I was good at math. I could make A's in math. Like a lot of what you talk about, I was a great memorizer. I took calculus all the way through college. I could not tell you what the quadratic formula means or probably even use it right now, but I made A's in my math classes. But I always remember feeling like I wasn't good at math because I felt I had to struggle so hard to earn those A's. And so I struggle in my teaching with how I was taught and what my education about teaching, how those kind of clash. And I have to unlearn how I was taught, if you know what I mean. And so I have never really thought, oh, yeah, I'm great at math. And I hear teachers all around me because I talk ad nauseum about math. And they're like, oh, you're so good. And you know all this and you know all that. And even still, I'm like, I'm not good at math. I work hard at math. And I've come to realize through readings, through Joe Bowler's work, that struggling doesn't mean you're bad at math. Struggling means you're doing math and you're exercising your brain. Like I talk to my kids about when you're struggling, that's a good feeling. You should recognize that as your brain is actually working. It's getting exercise. And when you come to that solution, when you've struggled and you get that aha moment where you're like, oh, wow, I've got it. And so I've really shifted my whole thought about who I was as a math student to who I am as a math person, and that there is no such thing as a math person, but everybody is capable of doing math at whatever level they want to do it at. They just have to recognize easy doesn't mean you're good at it, if that makes sense.
No, that totally makes sense. I often wonder because I always talk about this on the podcast as well, just this idea that I did well in math. And it sounds like maybe a very similar experience to yours, Karen, where I could do these things, but I never felt really good about it. I never necessarily felt like super confident. And I always wonder about that because even when you think about, you look at surveys on perceptions of mathematics and student perceptions of mathematics in particular, and usually they tend to be kind of low, even though there's a lot of students who we would deem successful in math because they get good grades. And it's only recently when I really started diving into research around like the 5 mathematical proficiencies, this idea that just because you can get answers in math class doesn't make you mathematically proficient. That's like one small chunk, one small piece of the pie. And, I wonder if maybe for you and for folks like myself, and maybe a lot of students that have been taught in a sort of traditional fashion or a traditional setting where they were able to come up with answers, but they didn't truly have confidence. They didn't have that productive disposition just because we didn't have the necessary conceptual underpinning in order for us to actually feel like we knew what we were doing. I don't know if that resonates with you at all, but for me, I know it certainly does.
It definitely resonates with me. I remember sitting in a training, and I think you said something like this in one of the podcasts or one of the things I was looking at, but I was in a teacher training for second grade math curriculum we were adopting, which was very hands-on, very spiraling. It was a very good curriculum. And we were working with tiles. And I was like, oh my gosh, a square number makes a square. That's why it's called a square number. Oh my gosh. And that was the first time I really thought, what have I been missing? What are all the little nuggets and secrets about math that I just never uncovered and never realized?
We've talked about that one specifically here. There's a lot of us math teachers who had that same epiphany, like what else are we missing? Or was I not shown? Or what else did I miss out on that was like this amazing kind of surprising element that I just wasn't shown in class? And I have that same thought. Like we've talked about the Pythagorean Theorem, like the idea that building on your example of squares is that a squared plus b squared equals c squared. And if you draw the squares off the sides, then the areas of those squares add to the bigger area. Like that was mind blowing to me and I didn't know that till as a teacher.
Yeah.
And I didn't know a lot of things until I was a teacher.
Yeah.
I always often wonder, even though we're showing our students these secrets that we see that is amazing, I still wonder if later on in life, if they became math teachers, would they be like, they would forget that and then all of a sudden be shown it again. It was like, this is amazing. I didn't realize this as a student. Like, are we missing? I often wonder if we missed it. Like, just maybe I was shown that. I just don't remember. I don't know. And I'm hoping, obviously, we're all hoping that that's not the case.
I wonder, too, if it's just like sometimes you're just not ready to experience something. It's like the timing just wasn't right for you. It could have been maybe a time in your life or just maybe like your maturity, right? And was I developmentally ready to experience that or to retain that? Or was I just distracted that day? There was something going on outside of class. And I often wonder about that, like how many things that now are realizations to me that maybe I've already bumped into 10, 20 times before, but they just never meant anything at the time. So that's always an interesting piece for sure. So I'm wondering, Karen, why don't we turn to and kind of get the wheels moving on this math mentoring moment? And I'm wondering if you don't mind sharing with us and the Math Moment Maker community, maybe any struggles or challenges, maybe a problem of practice that you might currently be working on right now. Is there anything on your mind lately that we might be able to dig into as a 3-person team here and kind of hash out?
Sure. I have a couple things that are going on always. The main thing that I find I struggle with every year is twofold. I have students who come in from second grade because I'm a third grade teacher, and they're like, I know all my math facts. I know all my math facts. I know my multiplication. I worked all summer long. My mom and dad worked with me, and I know all my math facts. And I'm like, that is so great. That's going to make some of what we do so much easier for you. But math facts are just a really small part of math. And we're going to learn a lot. And you're going to use those math facts as we learn them. But then as we get down to learning, the fact that they know their math facts impedes their willingness or their ability to not know that. So they don't get the discovery moment of the connection. So that connection of a square number makes a square, because I already knew like 2 squared is 4 and 3 squared is 9. I wasn't thinking in terms of what does that look like, or how does that appear, or why is that? I just knew it. And so I have this resistance from those kids to backtrack because they see it as, and I'm making assumptions, wild assumptions, I'm not in their brain, but is taking a step backwards. Like, I already know my math facts. Why are you making me do all this silly work because I know my math facts? As if that's all you have to do when you learn multiplication is your math facts. And I struggle with that. So I'm looking always for tasks and problems for those students to do that require them to stretch what they know about their math facts. So, for example, I did the massive mosaic 3-act today in class with my class. Started it because it takes us 2 or 3 days to actually get through these tasks. And I said, you must use graph paper, manipulatives. You have to show me your work. As I'm walking around, I want to see what you're doing and what you're discovering and how you're trying to solve this problem. And I walked by 2 students and they're sitting there. I'm like, I don't see anything out. What's going on? Oh, we already have the answer. We did all of it in mental math. And I said, oh, and I knew they didn't because it was 24 times 24. And we are nowhere near that in 3rd grade right now. And although these are really, really bright students, that was not, I picked this specifically so that those students would not be able to get the answer. And I said, guys, 1, this is what I asked you to do. 2, that's not the right answer. You need to go back to the drawing board and let's get some manipulatives out and let's see what you can use to try and figure out where your thinking has gone off track. And they were very, very resistant to that. And I don't even think they got very far down the road today. And so that's a very real struggle in 3rd grade for me, is to try and really get kids, 1, to use manipulatives, graph paper, pictures, show their work, and 2, not cling so much to those math facts.
Thanks, Karen, for sharing that. Let me just restate what I've heard, and just so that we are all on the same page. And I usually like to restate anyway, just so you've heard it back, and then you can make any adjustments as to what I have heard. So I guess what I'm hearing is that your kids are, you're studying math facts or different ways of doing multiplication, and you want your kids to be good with math facts. We all do. But some kids, maybe because their parents' influence, or maybe because they've learned some of these math facts along the way and elsewhere, the kids feel pretty proficient at math facts, like knowing what times what is what answer, and are resistant and hesitant to actually value the deeper learning you're trying to provide your students. And that is a huge struggle. So trying to get our students to see why we should represent things in different ways or try different strategies. You're not alone in that, but did I kind of summarize your struggle that you're currently having with your students accurately?
Yes, that was very succinct. I like the way you put that.
Yeah, so I think, I've experienced this in a high school level. I don't think it's something you're experiencing yourself. So I'm wondering, before Kyle and I kind of dig into this with you, is you recognizing this is huge already, right? Like, you recognizing that you want to provide this deeper experience for them, but they're just resistant to do that. What strategies have you put in place so far to kind of battle this?
Well, this first strategy I've really tried this year that seems to be working a lot better is just we call them notice and wonder problems, but it's your strategy for like 3-act tasks or G. Fletchy's stuff as well. It's just getting kids to look beyond the numbers. So just withholding all of that information so that they're just noticing things about the problem and they're wondering what's going on. And so they begin that thought process because they don't have any numbers to work with. So they're kind of, forced into that curiosity realm of, well, I don't know what's going on, and asking questions about what's going on. And that's really helped me to get past that first stumbling block of, especially in problem solving, because before I started using that strategy, we have a problem solving model that we use here at school. We use it throughout the district so that everybody's kind of on the same page when they go from class to class or from grade level to grade level. But every time you present them with a problem, it's a neat tidy little problem, and it's a word problem, and the kids are already tackling the numbers without really thinking about the processing of the problem. And so the 3-act tasks have been a boon to me as far as just getting those kids to slow down and just think mathematically and have conversations with other students in the class. And so that's really, like, that's where I'm at strategically. The first thing that I've employed that seems to have worked really well. I am embarking on opening up or starting our rotations or our centers. And today, the strategy I had for that, we haven't started them, but I asked the students to tell me what they thought would be productive for them in centers. I asked them to think about, what is it that you need to learn? What is it that's difficult for you? What is it that you would want to practice? And here's the things that you have to know before you leave 3rd grade. There's 3 main things you have to know. And so where are you in learning those 3 things? And what would help you practice and learn those better? And that's kind of where we are in that progression.
Yeah, no, I love that you're seeing the value in doing like a notice and wonder routine, and sounds like kind of following that curiosity path that John and I speak about in the early episodes. In episodes 1 to 4 of the podcast, we take a deep dive into the spark, fuel, ignite sort of 3-part framework. I'm wondering, after you were to intro a 3-act math task or any type of curious task, and kids are engaging in that notice and wonder, we're kind of withholding some of that information, then can you kind of paint us a picture, like, then when do things start to head towards that math fact, here's the answer, kind of like, let's move on and not really dive into the conceptual or the why behind it? What does that look like, sound like?
So what that looks like is we get through the notice and wonders, they turn and talk, do all that kind of stuff. Then we get to the point where they do estimations, and we're still good with the estimations because they really don't have enough information to really launch into anything. But then as soon as I do the reveal of, we talk about, okay, well, today we're looking for whatever it is, and I reveal the information that they can use to start solving it, they go straight for the calculation without a thoughtful processing of, why are they doing that calculation? Are they doing it correctly? Have they thought about how to use it? And so as soon as the numbers get introduced, that's where the wheels fall off. And it falls off for my really high kids, and it falls off for my really low kids. The ones in between that are used to struggle and working hard are like, okay, I got this. Let me get my manipulatives. Let me get all the things that I've got. Let me see what I can do to try and figure it out. And my highs and my lows are like, I don't know what to do with any of this. And my highs are like, I've got it. I've got the answer. Even if the answer is wrong, they really are very confident that they've got the right answer. And so my one strategy that I've tried to do recently is just pick problems that, while they're going to be really, really stretched for my lower kids, my higher kids, they're not going to get the right answer because it's something that they have to employ what they know about math facts to try and figure out how to answer the problem.
I'm wondering, like, what might be a recent task that you've used, just so we can kind of get you thinking about that particular experience? I'm kind of curious. I want to sort of frame something out here and just sort of get your perspective on it. So what might be a recent task that you may have used in the class?
Well, we did the massive mosaic today, and which was really interesting. It showed me a lot of things about my students, especially they're wildly inaccurate in estimating. So they were really interested in what it was. They had a lot of questions. We are not at the point where we have used the notice and wonder enough for them to really be getting to the math questions when we do it. There's still there's a lot of colors. It looks really pretty. I wonder who made it. Sometimes we get some really good math questions, and I'm like, oh, okay, great. They're asking some of the things that I need them to ask. Today wasn't quite one of those days, but we did come back from Thanksgiving break today, so maybe not the best day to introduce it. So I did say, well, I'm wondering how many tiles there might be here. And that's kind of how I launched that part of it. Then they were all like, oh, yeah, that's a really big picture. I wonder how many tiles are on there. And then they all rushed up to the board and started counting on the picture and trying to see how many. So they were all very interested in that whole aspect of it. And they've got their notebooks out. They have a partner, and they're talking with their partner, and all the manipulatives are out and ready for them to use. And I showed them the reveal of the 24 by 24. And that was where all 3 groups kind of did their normal business as usual kind of thing.
Yeah. Okay. Now that paints me like a really clear picture. And I know you mentioned this earlier, so I should have clued in. I didn't need to ask you what task you've done recently. But for this particular task, when students are now off to the races, and I can picture this, like I feel like I'm in your classroom right now, and I can picture those three sort of groups of students, right? Like those students who tend to take it and run, and then you've got those students in that middle sort of ground, and then you've got some students kind of throwing their arms up in the air. Let's say it's a student who goes straight to the standard algorithm, or what we in North America call the standard algorithm. They're different depending on where you are in the world, different standard algorithms. So if I'm looking at that and they're going, okay, 24, they stack 24 and then they put a 24 underneath. They do the ones first, then they do the ones and a tens, and then a tens and a ones and a tens and a tens, and they do all of this stuff right. My wonder is, what might we ask those students, or what might that sound like if that student does come in and let's say they do have the correct answer? What's your thinking there? And I know sometimes it catches us off guard because like, oh, you've got it. Now what do I say? I'm wondering, do you have any sort of aces up your sleeve there? Like when a student does do that, to hope that the learning doesn't stop there?
Yeah, if a student comes up to me with the right answer, I do a lot of times. I'm like, oh, okay, wait. But my normal response is, okay, that's great. How did you get that? Can you show me how you got that? Could you show somebody else how you got that? Could you teach somebody else how to do what you did? Is there another way that you could show me how you got that answer? And sometimes I'll get a half-hearted response of like, yeah, I guess I could probably go do something else. And some kids are like, yeah, I think I have got another way to show you. Those are my kind of standard strategies, is how else could you show this to me?
Yeah, that sounds like a fantastic approach. And I know for myself, and it doesn't always work perfectly, and some students are a little harder to kind of push than others. But something I've really found lately is really getting this idea of convincing your community, meaning that's great that you came up with this. Something that I really try to do now is I try not to actually give the students any indication as to whether they're on the right track or not. So for example, that student who comes running up to you with the standard algorithm, they've got it stacked and they're sort of like, here, look. Or sometimes they're sort of looking to you for like, can you confirm that I did this correctly? Like that this is correct? And it's really hard to do, but I try my best to say, I don't know, is it? And really, it kind of like deflects this idea that, listen, if you're coming to me to double check, then that means you haven't even convinced yourself yet. And really trying to come back to this idea of what are we valuing in our math class? Like, what are we after? Like, what do we want students to be able to do? And another thing too, that may or may not be happening, but in my classroom, anytime in this past year or two, I've really been a stickler. Every class I go into is a no calculator experience. So like everything we're doing today, we are not going to check with our like we have to find a way that we're going to be able to convince one another. And the way Karen does it might be very different than the way that I do it or the way that John does it. And that creates a great opportunity for them to practice that adaptive reasoning skill, like that ability to justify and to conjecture, to reason and prove. And really, when we do this, it sort of puts everybody in a place where it's like, you're going to maybe have to really think that through. And if you're not certain that it's correct, or that you're only looking to your neighbor to see if they got the same answer, like that's not enough to give you that confidence, you know, that you could actually stand up in front of a group of people and sort of advocate for this solution strategy.
Something else I tend to think about a lot lately is like the progression of learning. Like we got to know where they are. And when you do an activity like you've described, you learn a lot about your students. You learn a lot about who is doing what strategy. You learn a lot about who's, you know, you said you've got these other kids who are going straight to abstract or algebraic or just number sense or number crunching, but are skipping some of the things you want to see from them. But you've got kids who are diving into manipulatives. You got kids also who are struggling to get started. Like this is a lot of information that you learn about your students, which is awesome that you're doing this because, you know, we've talked about this a lot here on the podcast, is that when I didn't do these kind of activities, I didn't know any of that information about my students. I wouldn't know that until the test or the quiz or the assignment came back. And when I think about that, I think now, because I see all of that, you want to think like, what is the progression of where you want your students to go? Like think of a timeline, like, and not necessarily a timeline, but just a line of like, what are skills that they're progressing at? and where do we want those skills to end up eventually? And sometimes I think about this 10-10-10 rule. Where do I want their learning to go 10 minutes from now? Where do I want their learning to go 10 days from now? And then where should they be 10 months from now? And sometimes when I think about that in a classroom experience, when I'm seeing my students work and, doing some of these strategies, it gives me a lot of comfort about the 10-10-10, because sometimes I have to have a conversation with a kid to say, I think I got this, in 10 minutes, I think this learning is good, or I'm seeing what I think I need to see for where the student is at this point in the progression. And then the 10 months gives me a lot of comfort to say, I've got time to progress down this pathway for them. And not everyone gets to the end of the pathway. We know that the learning doesn't always work that way. And so that 10-10-10 rule helps me do all of that. But when you've got a student who you might think the end of the progression is this abstract multiplication, but you also want to do what you seem to be doing already, is just, if you're at the end of that progression, we should be able to move fluently from one side of the progression line to the other. We should be able to go back and go, okay, let's draw a diagram to represent this multiplication. How can you represent this as an array? How can we represent this in a different way, or in a number sentence, or in a different way? So I think knowing that progression and that landscape can help you decide where and what tip or what hint or what feedback to give the student to move them on that progression. If you think the 10-10-10 rule, you now know, like, in 10 minutes, I want them there, but in 10 days, I want them there. And in 10 months, I want them there. So I think kind of knowing these kind of things helps me in my class at a high school level push them in the right direction. And every kid's different. So I think we want to think long term, but I think short term, you get the freedom to think long term.
Well, and something else is, John, you're talking, and I'm thinking too, when we're asking students during class to do some of this work, and we go back to this idea of what we're valuing, sometimes we have to also sort of like zoom out a little bit and think about, so how am I going to assess and evaluate the students in my classroom? So for example, if, let's say, my written assessments are, and I'm going to just kind of call myself out on this, when I started changing my practice and started pulling in more tasks that were filled with curiosity and were what I would consider to be rich, because we can engage in these notice and wonder discussions and then actually get students into some powerful problem solving. I had those groups of students that were really kind of hard to shift away from this, like, listen, I got the answer, like, leave me alone, is kind of the hunch that I had when you would talk to some of these students. And what I realized afterwards was that if I'm giving them any sort of formal assessment and evaluation, maybe it's a quiz or a test of some type, and in younger grades, that looks different, of course. But if what I'm evaluating with my students is sort of what some of those kids are doing. So if, let's say, showing the standard algorithm is really all I'm after on any form of evaluation, then students kind of get that as sort of like what I need to do, and really all I need to do in order to get some of this work done. And it reminds me of a classroom I was in today, actually. We were doing a Context for Learning Math unit by Kathy Fosno, and this particular unit's called Muffles Truffles, and it was the first day of this particular task, and it's about essentially having all these truffles. It's a bakery, and the chef, his name is Muffles, and he has all these truffles, and we were working in a grade 4-5 class, and the idea was he would have these different flavors, like one's like vanilla, others dark chocolate, this is raspberry, there's all these different kinds, and they had different quantities. And he had boxes, and these boxes were 5 by 2, so 10 chocolates per box. And the big thing here was to get this idea that, like, if you had 273 vanilla truffles, that you could use 27 boxes. Like, you could see it in the number based on our place value system. And really, they're taking these numbers and dividing by 10. And at that age, some students weren't realizing that initially, but some of the students were able to pick up on this pattern that, like, if I just got essentially like took the ones number away, and they, kids were calling it things like crossing it out, or just like pulling it to the side and then using the other digits like that's how many boxes there would be. And some of these kids were really spinning their tires when I was asking them to convince me. And a lot of them couldn't. Like they actually couldn't because they didn't have the tools, the representations, like the mathematical models in order to actually convince me. And I also don't think that they really were at this level where they could actually think of how to convince me, right? They're still early on in their ability to reason and prove. So for us, we were thinking like there's two things we could do. We could continue nudging them to try to convince us somehow. I could propose ideas like, hey, I wonder if you were to draw a couple boxes, like, would that be helpful? And, if we're not making any gains there on some students, like the second thing we could do is like flip the script. And by flipping the script, it might be taking the context of the problem and changing it slightly. So now for these kids that are just looking at the number and covering up the ones column and saying that's how many boxes, but they can't explain why it works. Now what we can do is maybe introduce a different box, like a box that fits 8. Like now what? So now by flipping the script, it's like now I'm putting them in this place where it's going to cause them essentially to find the answer. They're going to have to represent it either concretely or visually because they aren't at the place yet where they have the standard algorithm, like the long division algorithm, most of these students. So those are some things to maybe consider as well when you get stuck in this place where you're really trying to push students for this convincing. I always say to some kids like, hey, if I have $1 million here and you have this one opportunity, and if I don't believe you, you don't get the $1 million. Are you confident that you've explained it as clearly as you possibly have? And some kids will say, yes, I am. And I'm like, sorry, you don't get the $1 million. I'm not convinced. Whatever you're doing, that's one way to do it. But then the other way is maybe I need to change something here. Maybe for this group of students or for this one student to get them to kind of get stuck in a place where their current understanding, like what they believe to be true about the mathematics, might not work out so nicely. Right? So what might that look like for the massive mosaic task where it's a 2-digit by 2-digit? Like, is there a scenario where you could flip something there that might put them in a place where they go, now I'm going to actually have to think about this. And I can't just turn to an algorithm to sort of save the day for me.
Right. Well, and that's actually why I chose the massive mosaic problem, because we don't do 2-digit by 2-digit here in Texas in 3rd grade. That's a 4th grade skill. And so I knew these students did not know how to do 2-digit by 2-digit. So I knew that they were going to have to do something else to convince me. And so that's where we're at. We stopped today. I stopped with a couple of kids. I'm like, I just flat out told them, like, no, that's actually not the correct answer. I do like the idea of saying, well, I don't know if that's the right answer or not. How could you convince me? I do like that. But for today, because I really wanted to try and have a conversation with them about what else could you do to show me? I was like, I want you to understand that what you think you're doing and the way the answer you're getting are two different things, because when they multiply, they got like 1,000 something. And I was like, no, we need to have a conversation. Let me see what you're doing, because they should be able to look at that and go, wow, that's too much. Like, even though they don't know how to do 2 by 2 multiplication, they do have enough going on that they should be able to look at that picture. And if they were using manipulatives, if they're using graph paper, they should be able to kind of see, hey, wait, 1,000, that's way too much. And so we're on a pause of that because we did not get the task finished today, and we're going to pick it up. But they did at the end of the day today. We're like, are we still going to get to work on this? Because they knew they hadn't finished it. They hadn't come up with the answer, which they're very keen on getting. And I said, oh, of course you're going to have more time to work on this. And so we'll have more conversations. All of the kids jumped in, and none of them really, like, I did have a few that were really struggling as to where to start. And so I was able to kind of launch them at each level wherever they were. Here, why don't you use graph paper? Why don't you use this? Because they are 3rd graders.
Maybe focus on this corner of the mosaic or something like that,
Right. Yeah. I mean, we are in 3rd grade and they are 8 and 9. And so they do sometimes need a little bit of scaffolding to say, well, maybe if you start at this point, based on what I know about them, I can kind of get them started. And then they have conversations and they take off.
Yeah. Well, we've chatted about a few different things here this evening, and Karen, I'm wondering if you have any, you mentioned one takeaway already, I think, just in passing just then, about you really liked the idea of not telling them that they're right away. And that's something that I've specifically learned from Peter Little, who called those proximity questions. Like if you're close, kids will say, am I right? And then you just keep walking away. Like, just don't let them know that they're right or wrong. Let them think, like Kyle suggested there. So are there any other big takeaways that you're thinking of now, either trying in your classroom, or you're like, I want to do that, or any other kind of big takeaway for you this evening?
I think one of the things just is the 10-10-10 really kind of helps me get a little more perspective. I feel like as teachers, a lot of times we have the standards that we have to get done, and we have this end of the year, and that's always looming. But if I can just parse it down to, you know what, let's see where we are in 10 minutes, 10 days. It just gives a little freedom to relax a little bit and realize it doesn't have to all be done immediately. They can't and don't have to know everything the instant you introduce it to them. I really like that idea. And then again, just the idea of not giving that answer away, I think that's one of the hardest things I struggle with, is to remember they don't need me to tell them whether the answer is right or not. They need to be the ones to feel confident in that. And so those are the two really big ones that I'm taking away tonight. I'm sure as I reflect, there will be other ones that come to mind, but those are the ones that are resonating right now.
Awesome. Well, you know what? It's so encouraging to hear someone who has taken and participated in the online workshop and is a part of the academy, putting that curiosity path to work and continuing to work through some of our current problems of practice. And like we mentioned in the online workshop and throughout everything we do, this is a process that takes time, and it sounds like you're making some headway, which is great. And I think even changing a little bit about how much and how quickly we come in to save students, I think is so important. It's something I still really struggle with, because we're so driven to try to get through stuff, right? We want to get through curriculum, and we want to make sure that we're on track, or, if you have a pacing guide or all of these things. But at the end of the day, it's like when we come in and save students, how often are students actually benefiting from that anyway? We feel this sense of relief, and maybe even they feel a sense of relief, but it doesn't necessarily mean that learning actually has solidified with those students. So I'd really love, if it's possible, if you can kind of keep us up to date in between for the next little while inside the academy and the community area. Like, keep us up to date. Let us know how things are going. And hopefully we can continue this conversation. And if it's okay with you, can we possibly invite you back maybe 9 to 12 months from now to kind of see how you're progressing, how things are shifting in the classroom, and basically kind of carry on from where you are at that point?
Oh, that would be great. I would love it.
Fantastic.
Awesome stuff. Thanks so much, Karen, for joining us here on the Make Math Moments podcast. And we look forward to keeping this going, and have a good rest of your evening.
Okay. Thank you so much. I enjoyed it.
As always, both John and I learned so much from these Math Mentoring Moment episodes. They happen to be some of our favorite of these podcast episodes that we record. But in order to ensure we hang on to our new learning so it doesn't wash away like footprints in the sand, make sure that you're doing some reflecting on what you've learned here today. An excellent way to ensure this learning sticks is to reflect and create a plan for yourself to take action on something you've learned here.
A great way to hold yourself accountable is to write it down, or even better, share it with someone, your partner, your colleague, or even a fellow math moment maker in the community over on Facebook. And you can tag us on social media at Make Math Moments.
We also want to take this moment to give you a quick heads up that our online workshop, Making Math Moments That Matter, will be open for registration next month in late April.
We run the online workshop twice a year, and we're running our second cohort for 2020 this summer instead of the fall. And if you're like Karen here and you are thinking about taking the workshop during 2020, then you won't want to miss registration this April of 2020.
Are you interested in joining us for an upcoming Math Mentoring Moment episode where you can share a problem of practice? Apply over at makemathmoments.com/mentor, and we'll work together as a 3-person team to help you overcome that problem of practice and develop some next steps.
In order to ensure you don't miss out on new episodes as they come out each week, be sure to subscribe on your favorite podcast platform.
Show notes and links to resources from this episode can be found at makemathmoments.com/episode 67. Again, that's makemathmoments.com/episode 67. Well, until next time, Math Moment Makers, I'm Kyle Pierce.
And I'm John Orr.
High fives for us.
And high fives for you.